All right, number 17. Let me get my share screen up. All right, so 17 was, all right, so it's kind of like the graph. I'll do like a rough estimate of the graph because I'm not able to put it on here. So it was something like this. And then was asking for the relative maxima and the relative minima. So for that one, what you had to do is basically it had, so like we'll say like, I think that's close to it. Yeah, it's actually decent enough. So this is its relative minimum. And then same thing on this one at the x value of x equals 2. So when you're finding your relative min and relative max, so relative min, you're just looking for the points in where it switches direction. So if you want to remember it, but it's kind of somewhat obvious in some sense. If it's at a peak, it's going to be one of your relative maxes. If it's one of your dips, it's your relative minimums. But you could also think of it, if it switches from increasing to decreasing, it's a max. And if it switches from decreasing to increasing, it's a minimum. But then you just observe at what x value this is happening. So this one, it's happening at x equals 2. And then this other one, it's happening at x equals -2. Now, some graphs might have the y value be able to just be seen on the graph. This one looks like it was somewhat difficult, so that's why they gave you the formula. So x to the third minus 12x plus 2. So now you take these x values and plug them into your function to figure out the y value. So I plug in 2. It would be 8 minus 24 plus 2. So that turns out to be -14. If I do the same for my -2, I get -8 plus 24 plus 2, and that ends up being 18. So my relative min is, so it has a minimum of my y value being -14 at the x value, x equals 2. You can word it differently. It doesn't have to be that exact wording, but somehow you have to say that at, so you can also say like at x equals 2, it's a minimum of -14. But you don't usually put those as a point. So your answer wouldn't be 2 comma -14 there. It's usually some sort of sentence. So your max, you could say that a max of 18 at x equals -2. So sometimes what could happen is you just read it off the graph. But in this case, they had you plugging into the function itself once you found those x values. And just make sure you be aware if there is one like this on the test. Let me scroll down a little bit. Say we have something that looks like, that's not a good arrow. It starts off constant and then kind of does like a parabola, something like this. This would be a minimum. So you could say that this is one of your relative minimums. But this right here is not a max. It has to completely change direction for it to be considered a max. But since it just goes to constant, it doesn't technically count as a maximum. Okay, more of the graphing ones. All right, let me see if there's another graph one. All right, let's do number 15. So number 15 looks like this. Let's make sure I get the right intercepts. And so this is what the graph looks like on 15. And then what it's asking for is its domain and range. So if we're doing the domain, and although the graph stops at some point, so like it cuts off at this square, the graph still keeps going. So whenever we're doing our domain, we're looking at what x values the graph covers. Unless there's some abrupt stop, like an asymptote, or if it's like a piecewise function where it kind of like breaks off, your domain is most likely negative infinity to positive infinity. And that's the case in this one because it just keeps going from left to right. And then still, when you're doing domain, make sure you're looking at really just the x-axis and not worrying about like if it goes up or down. With the range, then we start looking at the y values. So whatever my minimum is, well, that's negative infinity because it keeps going down. So that'll be my first one. And then I just look for its highest point. So it would be right here. It would be at y equals 4. So that would be my top. And then since it's included in the graph, it's a part of it. I put a bracket on that one. All right, let me see if there's any other graphings. Oh, they also said 16. So I'll keep on going in a row. So I'll just put 16 right here. So 16 is the same thing. It's asking, but instead of the domains and ranges, it's asking for the intervals of increasing. So you just have a parabola. It changes at 2, it looks like this. All right, so then the intervals of increasing, and it only asks for increasing. I'll also do decreasing, just so you have the example. Whenever you're doing intervals for increasing and decreasing, you only write down the x values. You take into account the y, seeing if it's increasing and decreasing. But when you're writing your intervals, you only write your x values. So my increasing one, well, it's increasing on this side and it switches at, that's the x value, x equals 2. And then another thing to remember when you're writing your intervals for increasing or decreasing, wherever the turning point is, it's not included in your interval. So I wouldn't be putting a bracket 2 here. I'd put a parentheses 2 because technically you could say that the value is both increasing and decreasing here. So we can't include it in one of our intervals. So we just put the parentheses and that keeps going till infinity. Decreasing is going to be the absolute opposite of it because it's everywhere else it's decreasing. So that's going to be a negative infinity to a 2. And then just something to be aware for those. A lot of people do tend to get tricked up with these. If say we have a parabola and say it looks like something like this, it's an upside down one. A lot of people, so you would say like from this on, it's decreasing, but then a lot of people write their interval as something like, let's say that value is 2, again, 2 comma negative infinity. Well, the range is going towards negative infinity, the y value is, but its x value is still positive infinity. So make sure whenever you're writing intervals, you still only think about the x values, even though it's going towards negative infinity on its x-axis, it's going towards positive infinity. Let me see if there's any more graphs.
Can you go over the third equation that's on 21?
Yeah. I can just do the whole 21 to graph that out because that's a good one to do. Right, 21. So it says f of x is equal to -5, -6, negative x plus 4. And then it goes, this interval is -7 is less than or equal to x is less than 2. X is equal to 2. And then x is greater than 2. All right, and then here is my graph. One, two, three, four. All right, so the first one, I'll be graphing from left to right. So it says from -7, which should be this one, and then to +2. So since it actually covers my y-intercept, I can actually use that in my part of the graph. So when x equals 0, y equals 5. And then since it's just x, that tells me it has a slope of 1. So then I'll just go down 1 over 1 going the other direction. It probably won't look that good. It ends up looking something like this. And then it keeps going for 2 more. So up to the point right here. I'm going to leave an open circle since it was a less than sign. Then at x equals 2, it's equal to -6. So it's something all the way down here. And that's an enclosed circle since it's equal to. And then -x plus 4. So since it's starting at the value 2, I'm going to plug that in for my x. So -2 plus 4, that equals 2. So then I know it starts at the point 2, 2. So 2, 2. And that's also an open circle. And then I'm just going to use the slope of the line to keep it going for however long. It's probably going to go until infinity. So then it's just down 1 over 1 for the rest of the graph. So if possible, use your y-intercepts if you can, if it does go through, if it does include x equals 0. If it doesn't, plug in like maybe your first value, or in this case, if you didn't have your x or your y-intercept, you could plug in your last value, see where one of those points is, and then just use your slope to go up or down. Any other ones before? I still have a few that she wanted me to go over. Yeah, so I can explain it again. So what I did was for my first one, so let's say x plus 5, since I knew it included my y-intercept, since x equals 0 is included in that interval, I used that as my first point. So I said when x equals 0, y equals 5. So I plotted that point right here. Then I looked just at the slope of the line, x plus 5, which is a 1 over 1 slope. So I went up 1 over 1, up 1 over 1 until my interval ended, and then down 1 over 1 until my interval ended on this side. So really there should be like a solid point here. For the second one, it strictly just says at x equals 2, it equals -6. So I just plotted my 1 point. And then for the last one, I didn't really have a y-intercept to work with. So all I did was plug in 2 for x to show where it started. And that got me 2. So that was telling me that on this last interval, it included the point 2, 2 and also started at the point 2, 2. So that's the first one I plotted. And then I did the same thing I did with the first one. I looked at the slope. So it's a -x. That tells me a -1 over 1 slope. So I went down 1 over 1, down 1 over 1. And that's for the rest of the time since it's x is greater than 2. So really for whenever these, you should kind of take it by parts. And really just think of it, you're graphing these lines and then just stopping where it tells you to stop. So maybe if you are really confused on the fact, like maybe this -x plus 4 doesn't go over the y-axis, well, you can graph it to x equals -x plus 4 to the y-axis. But then just remember when you're doing your answer, just erase it. And then it's still the same thing. that's something that you could do. All right. And then the one that she said to go over, I can do it quick because it is a short one, is number 18. Oh, I didn't take everything. I'm okay. So 18. It gives you a function equals x to the third plus x squared plus 3. And it's asking if it's even, odd, or neither. And then there's two ways that you could do this. If you remember the trick, then that makes it a lot easier. If you don't remember it, what you would do is plug in negative x for f of x. If it turns out to f of x, that means it's even. If it turns out to negative f of x, it's odd. And then if it does neither, then it's neither. What the trick is that you look at the powers of each of the components of the equation. So 3 is an odd number, so that number is odd. 2 is an even number, so that one's even. And then for our constants, we consider them even as well. That's the one thing you have to remember with this trick. Since we have two different ones, since it's both odd and even, that makes it neither. If we had something like x to the fourth plus x squared plus 3, since all of my components are considered even, that would be even. Something odd could be x to the third plus x. So that would be odd since we can consider x raised to the first, and both those are odd. Then you just have to be aware, like if this was x to the third plus x plus 1, that changes it to neither. So even though you can't really see the power of this constant, we consider it as an even. Any other specific ones you want me to go over? Because those were, you actually asked, all the graphing ones were the ones that she wanted me to go over.
Can you do either 5 or 6?
Yeah. All right. So use substitutions. So number 5, it gives us x to the fourth minus 31x squared minus 180 equals 0. Whenever it tells you like make the substitution, or if it specifically says like use substitution, whatever this is in the middle, set it equal to u. So we say u is equal to x squared. And then that naturally makes it so that u squared is equal to the first one, x to the fourth. So then now I can just write my u substitution. So u squared minus 31u minus 180 equals 0. And now it looks like something that I can work with. So I just have to find something that adds up to, or that multiplies to 180, that adds up to negative 31. And I would have no ideas off the top of my head, but their answer that they got is a negative 36 and a negative 5, positive 36 and a negative 5. Yep, I can do 24. So some ways that you can find this is it is such a big number. I kind of just test numbers in my calculator. I would divide 180 by like 2, 3, 4, and then maybe once you got to 5, you would see that those two numbers added up to negative 31. So then I'm just going to use it to split it. So u squared plus 36, u minus 5u minus 180 equals 0. So I get u parentheses u plus 36, and negative 5 u plus 36. So I get u minus 5 is equal to 0, and then u minus plus 36 is equal to 0. So my answers for u are 5 and negative 36. So then now you just have to remember to plug these back into what you substituted for. So we say 5 is equal to x squared, and then negative 36 is equal to x squared. Oop, I didn't even write the equal sign. Equal to x squared. So we take the square root of both sides to get rid of the squared. So I get x is equal to the square root of 5. I'm doing something wrong, because that's not right. I still did this wrong. This should be plus 5, it says. Let me work it back. I think I just got the signs mixed up. So it should be a minus 36, should be a plus 5. So then your answers are minus 5 and plus 36. So then let me just erase all this. So negative 5 is equal to x squared, and 36 is equal to x squared. Taking the square root of both sides, x equals plus or minus I to the square root of 5. And then this one is just x equals plus or minus 6. One good thing to check is whenever you're doing u substitutions, maybe you do forget that when you take the square root, you get plus or minus. Whatever your highest power is, that should be how many solutions you get. So there should be, so as we see, we have like 2 here because plus or minus, and 2 here plus or minus. That's a total of 4 solutions. Since I kind of butchered that, I'll do 6 as well, just to show the substitutions. So this one's a little bit weirder. So x to the negative 2 minus x to the negative 1 minus 30 equals 0. So as I mentioned, whatever is in the middle, that's what you make your u. So u equals x to the negative 1. So therefore u squared equals x to the negative 2. So we get u squared minus u minus 30 equals 0. Something that multiplies to negative 30 that adds to negative 1 would be negative 6 and 5. So I do u squared minus 6u plus 5u minus 30 equals 0. So u parentheses u minus 6 plus 5 parentheses u minus 6. So u plus 5 equals 0. U minus 6 equals 0. U equals negative 5. And u equals 6. So now plugging those back to my original, I get 6 is equal to 1 over, or I shouldn't write that yet. 6 is equal to x to the negative 1. And then negative 5 is equal to x to the negative 1. Now there's 2 ways that you could write this or solve for this. You can either raise both sides to the negative 1 power. So that would make the exponents cancel on this side, so you're just left with x. And then something raised to the negative 1 turns it into a fraction. So we get 1 over 6 and 1 over, or you could say negative 1 over 5. Another thing you could do is instead, you know that x to the negative 1 is also equal to 1 over x. So it's a little bit more work because then you'd multiply both sides by x. Divide by 6, divide by 6, x equals 1 over 6. Divide by negative 5, divide by negative 5. X equals negative 1 over 5. And that would be maybe if you forgot that you could multiply or raise this to a negative 1 power to cancel. So you could just solve it naturally. All right, I'll hop over to number 24. All right, so it says graph the equation y equals negative 3 over 4 x minus 2. And then the graph looks like this. 1, 2, 3, 4, 5, 6. All right, so whenever I'm graphing something, the first thing I always do is find the y-intercept. So how I do that is by plugging in 0 for x. Or you could just observe that the constant's negative 2. But if you do plug in x or 0 for x, you get y equals negative 3 over 4 parentheses 0 minus 2. So anything times 0 equals 0, so you get y equals negative 2. So that tells me that it crosses right here. And then now that I have this initial point, I'm just going to use my slope to go to the left and to the right. So since it's our slope equals negative 3 over 4, that tells me I go down 3 and over 4. So 1, 2, 3, 1, 2, 3, 4. That's close enough. And that's kind of as far that I can go on this graph to the right. If I was going to the left, then I just switch it. So up 3 to the right 4. 1, 2, 3, 1, 2, 3, 4. And that's really it. That's as many points as I can fit on my graph. Another thing you could do, which might make it easier, I think she did say she recommends that you plot as many points as possible, which you would plot as many as you could using this slope method that I just did. You could also find the x-intercept by plugging in 0 for x and solving, or plugging in 0 for y and solving for x. So we could say 0 is equal to negative 3 over 4x minus 2. If I add the 2 over, I get 2 equals negative 3 over 4x. Multiplying both sides by 4, I get 8 equals negative 3x. So my x-intercept is x equals negative 8 over 3. So not an exact point, but we can see, I mean, we were somewhat close. That would be your negative 8 over 3. So you could plot this point and your y-intercept. That gives you 2 points to draw your line through. But then obviously it wouldn't be as accurate because you may like not draw it as closely aligned this way and that way. So I would recommend this way because then you can plot more points and be more accurate. Any other questions? Uh, 20. All righty. Okay, so it's another one of those piecewise. Yeah, I did feel like she put a lot of these on the test review. It wasn't one that she recommended to me. Maybe she was hiding it. But they're also good to know just so you learn how to graph. So 20 f of x, x plus 4 and -1. X is less than 1. X is greater than or equal to 1. All right. So let me get my graph going. How far does it go? 5. 1, 2, 3, 4, 5, 6. I'll just do 6. 1, 2, 3, 4, 5. I'm just going to draw a bunch. 1, 2, 3, 4, 5, 6. 1, 2, 3. Okay, so one thing that I forgot to mention, I see on her like answer key here for the review, is whenever you have one of these piecewise things, one of the first things that you could do is make a dotted line where it changes. So for this one, it switches between the two different intervals at x equals 1. So you could draw your dotted line there to just let you know, like, hey, it stops here. And you kind of split your graph in half so that on this side over here, you're only focusing on x plus 4. And this side over here, you're only focusing on -1. So I always prefer to work left from right. So this first one, x plus 4. Well, that tells me that my y-intercept is 4. So I'm going to draw that point first. And then its slope is just 1 over 1. So if I go up 1 over 1, it reaches my line. It's just a less than symbol. So I put an open circle. Then I'll just keep going down 1 over 1 on this side. So that's my first side. And then if I go to my other side, well, it just says that when x is greater than or equal to 1, it's equal to -1. So that's just actually going to be a straight line. So it's included on that one since it's a greater than or equal to symbol. So it's a filled in line. And then I just draw as straight as possible a line going the other way. So it could definitely help even for the one where we had like 3. You could just draw 2 dotted lines on your graph to kind of tell you where to stop. And that might make it a lot easier to find like this point right here. Let me use this. This one right here. Any last questions? I'd be fine with going over the whole test review if you want, but I don't want to keep you here if you don't need any more.
8.
Did you say 8?
Yeah.
All right. Number 8. That's a good one. Yeah, so it just says solve the absolute value. So solve the absolute value. Plus 4 is equal to 11. All right, so the first thing you want to do whenever you're given an absolute value problem like this is to get the absolute value alone. So the only thing I have to do to the left side to get it alone is just subtract by 4 on both sides. So I get the absolute value of 5x plus 3 is equal to 7. And then now that my absolute value is alone, I can do the trick where I kind of break it apart into 2 separate equations. So I get 5x plus 3 is equal to 7. And then also 5x plus 3 is equal to -7. And this would be the same way of solving it if, say, this was like a less than or greater than. You still have to make sure you get all of everything but the absolute value away before you can split it apart into your positive and negative. And then now it's just solving for x. So -3. So 5x equals 4 and 5x equals -10. So I get x is equal to 4/5 and then x is equal to -2. And those are your two values. I can't remember if you do. Okay, that would be the same. This is very similar. So this one was number 8. This one is very similar to number 3, which was one of the ones that she had you do in class, where it was the 30x plus 15 minus 8 equals x. So you had to do the same thing. You can't really square both sides until you get this 8 moved over to the other side. So then you have the square root of 30x plus 15 equals x plus 8. And then that's when you squared both sides. And then big reminder with your square root ones, check your answers. So whenever you square both sides, one of your answers might not necessarily be true. So make sure when you do get your two values to plug them back into the original to see if they actually work. All right, any last ones? What are the types of questions where you have to check your answers? The U subs, I don't think you necessarily have to check your answers. It's not a bad thing to always check your answers, though. That's the teacher answer in me. So always do check your answers, especially when you're solving for x, because then it's very easy to just plug it back into your original and see if it works. But it's especially for these square root runs that you do have to. Because when you're squaring both sides, technically it could be like positive or negative. So that's where you sometimes get like the weird ones that you have to check. So I think that's the only problems that you have to, but that doesn't mean don't check your answers on your other ones. No problem. All right, well, thanks for coming. Hope you do well on your test.
I just found one more.
Yeah.
That can you do 27?
27. All right. I was so confused for a second because I literally did not see 27 on my paper. I thought you were joking with me. All right, 27. So 27 is graphing the equation. All right, and then this one, they're kind of mean and they don't give it to you in the correct form. So -3x minus 9y minus 18 equals x or 0. So the first thing you want to do is get it into your slope intercept form. So that means solving for y, getting y alone. So I'll just add 3x. And then also I can add 18 over to the right side. So negative 9y equals 3x plus 18. And then the last thing I have to do is divide by 9 or negative 9. So my solution is y equals 3 over negative 9 simplifies to a negative 1 over 3 x minus 2. And then now it's graphing time. They do like 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the first thing that I graph is my y-intercept. So my constant negative 2, that tells me that it crosses the y-intercept right here. And then I'll just use my slope from there. So down 1 over 3, down 1 over 3, down 1 over 3. And then going the other way, I'll go up 1 to the left 3. Something like this, and this, and this. So still not the straightest, but. So that one just really has that added step of actually solving for y first. Another one that could be tricky and that helps, knowing 27 helps with one of the ones that she highlighted. I think it was number 12. Not number 12. Number 23. Number 23, where you get the 2 points. So it just gives you 2 points, and then you're told to, it just asks for the equation in points or in slope intercept form, but it could be possibly that they ask you to graph it. So that one you just start by finding the slope, and then starting it in point slope form and then solving for y. So kind of same process here. We solve for y and then graph. That one you just have to solve for y to get your slope intercept form. Any more? Any more that you could find?
Do you know if there's a blank copy of the study guide on Canvas?
There might be. Let's see. Maybe it's under modules. Yep, right there. So if you go under modules, it should be under unit 2. Or is this
Thank
the
you.
key? I don't think she posted the key, she said. So this should just be the blank. Yep,
Okay, thank you.
no problem.